Namaste everyone, welcome to the class again. Now today in this lecture we are going to see evaluations of integrals which are of the type of 0 to infinity e power minus at into e power bt into f of t dt. Now whenever we say that we wanted to find the integral of the type 0 to infinity e raised to minus at into something, that means we will use the Laplace transform. Okay, Laplace transform, if you see the basic definition, it will be Laplace transform of f of t is same as 0 to infinity e raised to minus at into f of t dt. So evaluation of these kind of integrals is nothing but finding the Laplace transform. Now let us see the first example that we will discuss is evaluate. Here we will say that evaluate 0 to infinity e power minus t into sine t by 2 into sine hyperbolic root 3 by 2 into dt. We have to find integration of this type. Now to evaluate integral of this type, what we do, we first find Laplace of sine t by 2 into sine hyperbolic root 3 by 2. Okay, and then we use the definition of Laplace. So let us start. First, Laplace of sine t by 2. Laplace of sine t by 2, the coefficient of t is 1 by 2, so it is by definition 1 by 2 upon s square plus 1 by 2 square. So it will become 1 upon 2 into 1 upon s square plus 1 upon 4. So finally you will get 1 by 2 into this 4 will go up and denominator will become 4s square plus 1 is equals to 2 upon 4s square plus 1. Okay, you can simplify this denominator 4s square plus 1 whole divided by 4, that 4 will go in the numerator, right? So this is Laplace of sine t by 2. Now sine hyperbolic root 3 by 2 into sine t by 2 or sine t by 2 into sine hyperbolic root 3 by 2t. This is nothing but it is sine t by 2 into this we can write e power root 3 by 2 t minus e power minus root 3 by 2 t whole divided by 2. So this will become e power root 3 by 2 t into sine t by 2, 1 by 2 obviously we will take out, minus e power minus root 3 by 2 t into sine t by 2, here also 1 by 2 we take out. Okay, so therefore I will say that Laplace of sine t into sine hyperbolic root 3 by 2 t, this is nothing but 1 upon 2 Laplace of e power root 3 by 2 t into sine t by 2 minus 1 by 2 Laplace of e power minus root 3 by 2 t into sine 2 by 2. So by using first shifting theorem. Now what is first shifting theorem? If Laplace of e power at into f of t we want to find, then it will be equal to phi of s minus a, means wherever there is term a, it is replaced by s minus a. Okay, and if it is e power minus at, then wherever s there it will be replaced by s plus a. So our answer for sine t by 2 we have find out Laplace as 2 upon 4 s square plus 1. So it will become 1 by 2 into 2 upon 4. In place of s, I will write s minus root 3 by 2 t, root 3 by 2 the whole square plus 1 minus, here it is 1 by 2, 2 upon s plus root 3 by 2 the whole square plus 1. So this is equals to, we can cancel this 2. So this becomes 1 upon 4 times s minus root 3 by 2 square plus 1 minus 1 upon 4 times s plus root 3 by 2 the whole square plus 1. This is Laplace of sin t into sin hyperbolic root 3 by 2t. So therefore, I will say that by definition of Laplace transform, integration of 0 to infinity e raised to minus st into sin t by 2 into sin hyperbolic root 3 by 2t into dt. This whole will become 1 upon 4 times s minus root 3 by 2 the whole square plus 1 minus 1 upon 4 into s plus root 3 by 2 the whole square plus 1. Now we will put s is equals to 1. As per problem, it is e power minus t. So therefore, I get 0 to infinity e power minus t into sin t divided by 2 into sin hyperbolic root 3 by 2 t into dt. This will become, this is equals to 1 upon 4. Now in place of s, I will put 1. So 1 minus root 3 divided by 2 the whole square plus 1 minus 1 divided by 4 times 1 plus root 3 by 2 the whole square plus 1. Now we will simplify this. So for simplification, we will take cross multiplication. So here 4 times 1 plus root 3 divided by 2 the whole square plus 1 minus 4 times 1 minus root 3 by 2 the whole square plus 1. Okay, this I will take in bracket and whole divided by, here we will multiply them. So here 4 into 1 plus root 3 by 2 t the whole square plus 1 into 4 times 1 plus root 3 by 2 the whole square plus 1 is equals to numerator, it will become 4 into, we have 1 plus 2 into ab, so root 3 plus 3 divided by 4 plus 1 minus, here it is 4 into 1 minus root 3 plus 3 divided by 4 plus 1 and whole divided by denominator. In the same way, it is 4 into 1 plus root 3 plus 3 divided by 4 plus 1 minus 4 into, here it is multiplication, this whole term is multiplied by 4 into 1 plus root 3 plus 3 by 4 plus 1 is equals to, we open this bracket, so it is 4 plus 4 root 3 plus 3 plus 1 minus here it is 4 minus it is plus 4 root 3, then it is minus 3 by 4, and then it is minus 4 minus 1 whole divided by. Now in denominator we open this bracket, it is in one bracket it is 4 plus 4 root 3 plus 3 plus 1, in other bracket we have 4 plus here it is at one place it is plus and other place it is minus. So in one bracket we keep minus sign and in one bracket we keep plus sign. So let us take here it is minus, so this is minus, here it will be minus, here it will be minus. Now here it is plus sign, so 4 plus 4 root 3 plus we have denominator we are multiplying, plus here we have 3 and plus we have 1. Okay, so now this 4 and this 4 we cancel. This is 4 into 3 by 4 is 3, but this is minus 3. So I will write minus 3. Now minus 3 plus 3 cancel, plus 1 minus 1 cancel. So 4 root 3 plus 4 root 3, I have 8 root 3 in numerator, and my denominator will be 4 plus 3 plus 1 4, 4 plus 4 8 minus 4 root 3, and here it is 4 plus 4 8, 8 plus 4 root 3. So I will take 4 common, 8 root 3 divided by, I will take 4 common from here, 4 common from here. So here it is 2 minus root 3 and here it is 2 plus root 3. So this 4 1s are 4, 4 2s are 8, 2 1s are 2, 2 2s are 4. I will get root 3 divided by 2 into, now a plus b, a minus b is a square minus b square. So finally root 3 upon 2. So root 3 upon 2 is the solution. We could have simplified it at the level of s or here also, no problem. So this is our required result. Yes. So this is how we evaluate. Let us see few problems more. So first problem we will take as we want to see the problem of evaluation. Evaluate the following. Okay. Problem is evaluate zero to infinity e power minus t into we have t square minus 3t plus 5 plus e power 2t into t square into dt. Okay, so we have to evaluate this part. So let us see one by one. First we will see Laplace of t square. What is Laplace of t square? Laplace of t square, Laplace of t power n is gamma n plus 1 or n factorial, so that is 2 factorial upon s power 3. Laplace of 3t it is 3 into 1 factorial, that is 1 upon s square. Laplace of 5, it is 1 upon s, and Laplace of e power 2t into t square. So the Laplace of t square we know it is 2 upon s cube. So Laplace of e power 2t into t cube, it will be 2 upon s will replace by s minus 2 the whole cube. Okay, so therefore using this I can say that therefore Laplace of we have t square minus 3t plus 5 plus e power 2t into t square, e power 2t into t square. Laplace of all these terms is equals to, it is 2 upon s cube minus 3 upon s square plus 5 upon s plus 2 upon s minus 2 the whole square upon the whole cube, not whole square. This is Laplace of this. Therefore integration using definition of Laplace, we say that integration of 0 to infinity e raised to minus st into t square minus 3t plus 5 plus e power minus 2t into t square, this is equals to 2 upon s cube minus 3 upon s square plus 5 upon s plus 2 upon s minus 2 the whole square. This is 0 to infinity e raised to minus st into this. Now we want to find e power minus t. Here in place of e raised to minus st we have e power minus t. So we will put s is equals to 1. So therefore I will get 0 to infinity e power minus t into, here we have t square minus 3t plus 5 plus e power minus 2t into t square into dt. This is equals to 2 upon s cube. So in place of s we have 1, so it is 1 cube, so 2 upon 1 minus 3 upon 1 plus 5 upon 1 plus 2 upon 1 minus 2 the whole cube. Okay, here it is whole cube. So on simplification we will get 2 minus 3 plus 5, 1 minus 2 is minus 1 cube is minus 1, so minus 2. So minus 2 plus 2 cancel, 5 minus 3 is 2. So 5 minus 3 is 2. So this is your final answer. Right, done. Okay, now we will see second shifting theorem. Okay, second shifting theorem. Second shifting theorem. Now the statement is, if Laplace of f of t is phi of s, if Laplace of f of t is phi of s and g of t is equals to f of t minus a when t is greater than a, and g of t is 0 when t is less than a, then Laplace of g of t is equals to e power minus as into phi of s. Have you understood the statement? If Laplace of f of t is phi of s, and g of t is function of t minus a for t greater than a, and it is 0 when t is less than a, then in that case Laplace of g of t is equal to e power minus as into phi of s. Let us try to prove it. Now Laplace of g of t, by definition it is 0 to infinity e power minus st into g of t dt. Here I will split this limit between 0 to a e power minus st into g of t dt plus a to infinity a raised to minus st into g of t into dt. Now when t is less than a, the value of g of t is 0, so this whole part will 0, and I have only from a to infinity e raised to minus st, and here in place of g of t we have f of t minus a into dt. So now here I will do a substitution. I will say put this t minus a, I will use any other symbol, say u. Therefore our dt will become du, and t will become u plus, it will become u plus a. Also when we check the limit for t, so as t tends to a, as the value of t is a, the value of u will be 0, and as t tends to infinity, u will also tend to infinity. So therefore I will say that Laplace of g of t is equals to, now my limit will change from 0 to infinity, e raised to minus s, in place of t I will write u plus a, into f of, in place of t minus a I will write u into du. So this is equals to e power minus as. Now this minus a is common or constant, I will take out. Here it is 0 to infinity e raised to minus as into f of it is e power minus su, e power minus su into f of u into du. So I can use variable t in place of u, we can change the variable, so it will become e power minus st into f of t into dt, and this is e power minus as into phi of s. Hence proved. Now generally in Mumbai University you will find a problem to prove this second shifting theorem, but you will not get any problem on the second shifting theorem. The reason is that whenever the problem comes for this second shifting theorem, that you can find using the principle, first principle you can say, or you can say that the definition of Laplace. So using definition of Laplace you can find its value, but proof is generally asked. So we have discussed here proof for the second shifting theorem. Now let us see next topic, that is effect of multiplication by t. Effect of multiplication by t. So here the statement is, if Laplace of f of t is equals to phi of s, then Laplace of t power n into f of t is equals to minus 1 raised to n into d power n upon ds power n into phi of s. So we can prove this by the method of mathematical induction. Now, what is mathematical induction? So that you have already covered in your 11th standard, in which we follow some steps. So step number 1. In step number 1, we consider let Laplace of f of t is equals to, this is by definition 0 to infinity e raised to minus st into f of t dt as phi of s. Okay, Laplace of f of t we have taken phi of s. Now we differentiate both the sides. So therefore I have phi of s is equals to 0 to infinity e raised to minus st into f of t dt. Now differentiating both sides with respect to s, with respect to s and applying the rule of differentiation under integral sign, we get phi dash s. Differentiation of phi s is phi dash s is equals to 0 to infinity. Now here I will differentiate, so it is del upon del s. We have to differentiate this whole, which is e power minus st into f of t dt into dt. So derivative of e power minus st, it is 0 to infinity, we will get minus t into e power minus st, because coefficient of s is minus t, so minus t into e power minus st into f of t dt. This is phi dash s. So this is nothing but Laplace of, or I will take this minus sign out, minus Laplace of t into f of t. So therefore I will say that Laplace of t into f of t is equals to minus of phi dash s. Now minus phi dash s means it is minus 1 into d by ds of phi of s. Now let us see what we have to prove, that Laplace of t power n f of t is minus 1 power n d by ds into phi of s. So here this minus 1 we can write as minus 1 power 1 when we have multiplied it by t. So thus I will say that in step number 1, thus the rule is true for n is equals to 1. Means here t power 1 we have taken. Now in second we assume that it is true for n is equals to m, and we have to prove that it is true for n is equals to m plus 1. So in step number 2 we say that let us assume that it is true for n is equals to m, and then we have to prove that it is true for n is equals to m plus 1. Okay, so we assume that it is true for n is equals to m, that is Laplace of t power m into f of t is equals to minus 1 power m into d power m upon ds power m into phi of s. So we consider this is true. Now first we have proved that if I differentiate one time I will get minus 1 power 1 upon d by ds into phi of s. Secondly, I prove that this statement is true. Now I have to prove that it is true for next step also, that is for if I use in place of m, if I use m plus 1. So Laplace of, here we got Laplace of t power m into f of t. Now if I use definition of phi of s, I will say that this is equals to 0 to infinity Laplace of f of t, this phi of s. So in place of Laplace, what I will say that therefore minus 1 power m into dm upon ds power m into phi of s, this will be equal to 0 to infinity e raised to minus st into t power m into f of t dt. Now I will differentiate again. So differentiating both side with respect to s and applying DUIS, differentiation under integral sign, on right hand side. So I will get, I differentiate one more time, so here it will become minus 1 power m, this will become d power m plus 1 upon ds power m plus 1 into phi of s is equals to, here we differentiate, so it is 0 to infinity. Now differentiation of t power m f of t dt, all these are constant, only this is variable, here variable is involved. So it is minus t into e power minus st into t power m into f of t into dt. So this is equals to, now you will see that it is minus minus, I will take out, Laplace of this will become t power m plus 1 into f of t dt. Now this minus I will move on left hand side, or I will say that therefore Laplace of t power m plus 1 into f of t is equals to, now this minus which is here, it will move on this side and we get minus 1 power m plus 1 into d power m plus 1 upon ds power m plus 1 into phi of s. So thus the property is true. So thus it is true for n is equals to m plus 1. Therefore I will say that by using step number 1, 2 and property of mathematical induction, or simply therefore I will say that therefore by using property of mathematical induction, we have Laplace of t power n into f of t is equals to minus 1 power n into d power n upon ds power n into phi of s. So what is mathematical induction? Okay, property of mathematical induction. In generally in 11th standard it is taught to you that if there is some statement and you wanted to prove it, then there is one more method where what you do, you first prove that the statement is true for n is equals to 1, then you assume that it is true for n is equals to m, and then you prove that it is true for n is equals to m plus 1. And if you are able to prove that it is true for n is equals to m plus 1, then the statement what is given to you for proof is perfect, is right, is correct. So this is principle of mathematical induction. Now with the help of mathematical induction we have proved that Laplace of t power n into f of t is equals to minus 1 power n into d power n upon ds power n into phi of s. So let us see one problem based on this, and then we stop for today and see other problems in next class. So we will take one problem. Let us take problem as find Laplace transform of t into e power minus t into cos hyperbolic 2t. Okay, so we have to find Laplace of t into e power minus t into cos hyperbolic 2t. So let us see how we do this. First, we know by definition that what is Laplace of cos hyperbolic 2t. Cos hyperbolic 2t is nothing but it is s upon s square minus 2 square. This is Laplace of cos hyperbolic 2t. Then I use first shifting theorem. So using first shifting theorem, I can say that Laplace of e power minus t into cos hyperbolic 2t is equals to, I am applying first shifting theorem. So in place of s, wherever s, I will replace that s with s plus 1. So it will become s plus 1 upon s plus 1 the whole square minus 2 square is 4. Then by using property of multiplication by t, so by property of multiplication by t, we will say that Laplace of t into e power minus t into cos hyperbolic 2t is equals to, here it is minus 1 power 1 into d by ds into, here it is s plus 1 upon, if I expand it, here it is s square plus 2s plus 1 minus 4 is minus 3. So that means we have to use derivative of this. So u upon v method we will use. So this is s square plus 2s minus 3 into derivative of s plus 1 is 1 minus I have s plus 1 and derivative of s square plus 2s minus 3 is 2s plus 2 and whole divided by we have s square plus 2s minus 3 the whole square. Okay, here in the beginning I have minus 1, so minus sign I will put minus. I can write minus 1 also better. So this I will simplify. Numerator I have s square plus 2s minus 3, then here it is minus s into 2s will be minus 2s square, then it is minus 2s, then again we have minus 2s, then we have minus 2 whole divided by here we have s square plus 2s minus 3 the whole square. Now 2s minus 2s cancel. Okay, s square minus 2s square is minus s square, so minus s square minus 2s, then minus 3 minus 2 is minus 5 upon s square plus 2s minus 3 the whole square is equals to, now minus I will take out and here I have s square, here also we have minus sign, so this minus is there already, 1 minus I have here, so this minus minus it will become plus and it is s square plus 2s plus 5 upon s square plus 2s minus 3 the whole square. That's it. Okay, so we will see you in next class with a few more problems. Okay, thank you for being with me in this class.